Hi, I'm Maheen from AWS.
Hi, I'm Yogesh from Noventiq, and this is my architecture.
So today we are going to talk about a data processing architecture pattern using AWS OpenSearch. So Yogesh, I understand you did this for Cybex. So what was the customer challenge you were trying to solve?
Yeah, so Cybex is in the business to provide trade data and reports related to the export-import. They had around 1.5 billion of records. Initially, they used to serve their customer in offline mode. So every time customer had a new requirement, whether it is related to a new product or say new country, the entire process to understand the requirement, to book the order, then churn the data, and then serve the report, it used to take a couple of days, right? So they wanted us to provide a cloud solution which can provide flexibility to their customers to get data at any point of time from anywhere within few seconds. First of all, the raw data, which is in the format of the CSV or in the Excel file, it's get uploaded into the S3 buckets. Then a Lambda get triggered to validate this data. If there is any discrepancy within the data, then it gets highlighted here. Else, a copy of the validated data get uploaded into a different folder within the S3 buckets. Once we have the validated copy here, then the Lambda get triggered to process this validated data and ingest it into the OpenSearch cluster. Here we are doing few more activities, like we are creating the query templates and mapping them with the relevant indexes. Secondly, we are using the Amazon OpenSearch Analyzer to fine-tune queries and enhance performance. And then an aggregated layer is being built on top of the processed data to serve the complex reports like the trained analysis report or some other aggregation reports.
So Yogesh, I see you've used an event-driven architecture in this particular instance. So why the event-driven architecture?
Yeah, so as I mentioned earlier, when we designed this architecture, at that point of time, we had around 1.5 billion number of records. But over a period of time, this number has been increased by more than 3.5 times. Now we have around 5 billion of records. But still, application is able to provide data and trade reports having 15 to 20 complex parameters within 2 to 4 seconds, right? So you can understand that there is no such latency with the huge increase of the number of records using the same architecture.
Thank you for explaining how data ingestion works. Tell us how the user is able to then get access to this data.
So we have designed two ways to retrieve the data, right? User can access the data either using the web application or they can use mobile application to retrieve the data. So in case of the web application, user sends the request to the front-end application via the web browser. It has been developed using the Angular. And then the request goes back to the browser and then it comes back to the back-end application, right? So this backend application we have developed using the Python. Then request goes directly to the data layer and then response sends back to the user via the backend application. While in case of the mobile apps, request goes directly to the backend application and then to the data layer and then response comes back.
And early on you mentioned 5 billion records. How do you keep the costs down for that kind of volume?
So you can see, right, we are using the Graviton 2 instance for the Amazon OpenSearch. So it helped us really to optimize the cost, right? Initially, if I will compare from the beginning, right, we are saving something between 25 to 30% of the operation cost, which is roughly equivalent to the $100K.
And when you were explaining the challenge, you mentioned that sometimes reports can take longer to run than the normal latency. So how do you give the best customer experience using this?
Yeah, it happens sometimes, right? Sometimes user request for a report having more than 10,000 records. Then at that point of the time, we upload the report in this S3 bucket and then send an intimation to the user via SES to download this report using the pre-signed URL.
That's great for security as well. Yogesh, thank you for sharing your fantastic architecture with us today.
Thank you. Thank you.
And thank you for watching another episode of This is My Architecture.
Thanks, everyone.